who basically is a tool or a software which allows us to create wonderful visual interpretation of graphic data and present it to the user the way they would love to see it. So a picture is worth much more than 1,000 words. So without much ado, I would hand it over to Shraddha from the Linkurious team, where the artists start painting it for you, the basic simple textual data brought to you in life or trying to present to you in life in a way that you would love to see it. Over to you, Shraddha, and the rest of the team to follow. Thank you so much, Deepak.
Thank you, Deepak and Sridhar. Hello, everyone. Thanks for joining us today and welcome to this webinar. So as Sridhar said, indeed, the greatest value of picture is when it forces us to notice what we never expected to see. And today we want to show you this picture of Linkurious, which can help you unlock true potential of your data. So I'm Shraddha, Customer Success Manager at Linkurious. And along with me today, I have Andrea.
Hello, everyone. My name is Andrea, and I'm a solution engineer at Linkurious Enterprise. And my role is to help our customer dealing with technical challenges and ensuring they gain the most value out of Linkurious Enterprise.
Thank you. The agenda of our presentation today will be introducing you to Linkurious and showing some of the features and capabilities which would include API, timeline, graph queries, and access rights. I'm going to explain these further on with the help of a use case within a bank. To begin with, let me provide a brief introduction of what Linkurious is. So Linkurious Enterprise is an on-premise graph visualization and analysis platform that helps our analysts to detect and investigate threats in complex data sets. And in a few minutes, we'll show you how. Linkurious as a company was founded in 2013, and currently we are a team of around 40 people based in Paris. As of today, we have thousands of investigators in different organizations worldwide using Linkurious Enterprise actively. So quickly, let me take you through the use case. Let's assume we are a bank and we want to investigate customers for activities related to money laundering or any suspicious activities. In the bank, there exists an internal application or a Power BI dashboard, which gives me a risk score or sort of a red indicator for a specific customer. Now I want to have a 360-degree view or a single customer view for this person to visualize his network of connections. So Linkurious API help here by integrating your internal application, which in this case is Power BI dashboard, and provide seamless navigation from your application to Linkurious interface. Let's assume I have reached the Linkurious interface, and now as a first step, I'm part of a transaction monitoring team, and I want to do a transaction analysis over time to visualize my customer transactions to detect if there are any anomalies or any abnormal transactions which has happened over time. Here, Linkurious Enterprise offers you a very interesting feature called timeline, which helps you to perform temporal analysis. Let's say with the analysis, when we were performing these temporal analysis, in this step, I found a suspicious transaction, and I decide to pass this case to my fraud team for deeper investigations. So now I am a fraud analyst and fraud team who got this case from the transaction team. I know that I perform some similar steps to perform these kind of investigations. These similar steps could be exploring the connections till 4 hops, or finding the shortest path to see the connections between two persons or person in a company. This process can be really automated and performed in one click by using Linkurious queries. Queries can really act as a booster for analysts to make quicker decisions. So it makes your process faster. With this, as a fraud analyst, I've completed my investigation, and I know, Andrea, could you please, thank you. So, and I know that this customer is indeed suspicious. But within the process, we have to take care of one very important thing, very important aspect, which is having the right access to data. Different teams should have access to the data they are entitled to. For example, only senior analysts should have access to sensitive data, but junior analysts should not. Or transaction monitoring team should have access to only transactions, and fraud team should have more broader view. How do you handle that? Linkurious here helps you set up the access rights based on your requirements. So as by now I've made you familiar with the use case which we will be using today, I want to hand it over to Andrea to show you the real demo to see all these features within the Linkurious interface. Over to you, Andrea.
Thank you, Sharda. So our demo, we start with API. And when talking about integration, API are for sure the most powerful tool that you can have. And for this reason, Linkurious Enterprise comes with a REST API server that is embedded inside the Linkurious Enterprise application. Generally speaking, we offer two different types of API. We have the first type that is what we call backend API. That kind of API allow you to check or manage the server or to export information from a visualization, or generally speaking, export all the information that are contained inside the Linkurious Enterprise server. The other type of API are the front-end API. By calling this API, the server will return a Linkurious Enterprise user interface, such as, for example, a visualization, a widget, a configuration page, or an alert page. So let's jump into the demo. Today, as said by Shraddha, I'm working in a bank and I need to analyze some suspicious customers. And as you can see right now, I'm in Power BI, in a Power BI report, where I have some charts. I have a table of containing some people. And as you can see, this is a table that's containing actual data. These are data coming from the bank database. More specifically, in this case, the table is filled with the information that are extracted from the Linkurious Enterprise alerts. And this is done by calling one of our backend API. And as you can see here in the right side, I have a button. And if I select one customer, like in this case, Timmy Quibbot, if I click on this button, I can open an Linkurious Enterprise user interface. In fact, the button in Power BI is basically an API button that's called a front-end API. And now I'm in the full Linkurious Enterprise application. I can perform my investigation. I can expand nodes. I can do whatever I want. And always talking about integration, we have another feature that is called custom action that allows me to call basically external front-end API. In fact, if I right-click on Timmy Quibbot, as you can see here, I have a button called custom actions, and I can click on show on Power BI, and the users is directly redirected to Power BI with the filter on Timmy Quibbot. The next topic for the demo is timeline. Depending on your use case, timeline could be the key element in your investigation. Linkurious Enterprise basically allow you to filter your visualization, your graph, based on date or datetime properties. This is something that can really help you in stay focused only on the relevant information and to remove some noise from the visualization. Let's go once again in the demo. So right now, I'm an analyst that belongs to the transaction monitoring team, and I need to understand why this person here is considered suspicious. So what I want to do is to see all the transaction that has been performed by Timmy with the central bank account. That is the account of my bank. And if I expand it, as you can see, there are a lot of transactions, and it might be difficult to understand what's going on in this case. But what I can do is basically to click on the clock icon here and select the property that I'm interested in. In this case, I want to analyze the hard transfer hedges. And as you can see, I have now a bar chart with all the transaction that has been performed every single month. From here, I can change the zoom. So I can go to yearly transaction. I can see the transaction that happened every year. But in this case, I want to be focused on month. What I can do is basically to move the slider here. And as you can see, what I'm doing right now is basically to travel in time. I'm going back to time. I can see the evolution of the account, all the transactions that are going to be populated in my visualization. And here is something that can really help me in staying focused only on what I need to see. So let's say that I'm only interested in transaction in the 2020. I can basically put a lower bound and an upper bound in my filter. And now I can only see the transaction that happened during this year. Another thing that I can do, since there are still some extra edges, is to group all these edges in single edges. What I can do is to call the edge grouping feature in Linkurious Enterprise, and by clicking on this icon, once again, I can select the edge type as transferred. And as you can see right now, I can only see the transaction in a single edge. So basically, all the transaction has been collapsed in a single edge. In the next part, we talked about graph queries. Generally speaking, Linkurious Enterprise was created with the intent of being easy to use, but without losing the expressiveness and the power of the graph database. In fact, as you might know, Linkurious Enterprise works over a graph database that might be Cosmos DB on Neo4j. And this kind of graph database have a very powerful query system. Like in the case of Neo4j, we have Cypher queries. And these kind of queries are still available in Linkurious Enterprise. So generally speaking, user can expand nodes without the need to write any code. But if they want to, for example, to tackle more complex task or maybe to facilitate some operation, they can still write some queries. And in Linkurious Enterprise, we have two different types of queries. The first one is are the standard queries, are basically the queries that are in the native language of the graph database. And then we have query templates. A query template is a dynamic query that's changed according to the data that you have in the visualization. So it's something very useful for users that cannot write queries by their own. And in fact, with query templates, you could have a data scientist in the team that's write a single query that can be shared and reused by all the members in the teams in different situations. We can go in the demo once again. So now I belong to the fraud analysis team, and I need to go on with the investigation. So the first thing that I want to do is to mark this user as suspicious, because if I'm arriving at this point of the investigation, maybe this person is really a frauder. So I want to tag it as suspicious. And what I can do is to call a query template that is called tag as suspicious and comment. Basically, by calling this query template, as you can see, I'm running a query that will be executed on the node team query block. And what I can do is to have a comment. This comment will be basically stored inside a property of the nodes. And as you can see, as soon as I execute the query, also the style of the nodes change. In fact, what I do in the query template is also to have an extra flag for the nodes that is called is frauder. Where is it? Sorry, the property is called suspicious, that in this case has been set to true. And based on Linkurious Enterprise styling rules, I'm able to change the style of the node. So this way, all the members in my team are aware that this person is suspicious. So another thing that I want to do is to understand what's going on around his mortgage loan. So if I expand the node, as you can see, there are two different companies. One is a realtor and another one is a broker. I can switch to the geo mode, where basically we are able to locate all the nodes in a map based on geo coordinates. And as you can see here, the case is quite strange because we have the customer that is in this state, but both the realtor and the broker are in different states. So according to the my bank policy, this is a very strange situation, and this requires a deeper investigation. So now what I want to do is to see who are the person behind this, the realtor company. And one thing that I could do is to expand the notes, trying to maybe to find the UBO for this company. But this is something that can be done a lot way easier by writing a query. So in this case, I have a query template that can really find the UBO with a single click. In fact, if I go on the company notes, I can right click on it. I can call the query, and I have a query that is called get UBO. And as you can see, in a single click, I already have the UBO for the Betelgeuse housing market company. So now I want to see if maybe there is some correlation between Timmy Greenbot and the Alan Parish node. So what I can do is to select that two nodes and call another graph query that is the find shortest paths. This is a query that's try to see if there is a connection between two nodes. It's something that can be configured. So according to your needs, we can set the maximum path length or the maximum number of paths. I can run it, and as you can see, there is a correlation between the two bank accounts, between the Timmy Greenbot bank account and the Alan Parish bank account. This is something that is filtered, so it's something that did not happen in the 2020, but by going once again in the timeline, I can remove the filter. And in fact, it's something that happened basically in September 2020, so out of the previous filter. And now it's clear that, oh, sorry. It's clear that there is a very strange situation. In fact, Timmy Greenbot has a mortgage loan with a company that is in another country. And this country, this company has an UBO that shares some money with Timmy Greenbot. So it's a very, very strange situation. And from here, I can say for sure that Timmy Greenbot is a frauder, and there is a fraud behind this mortgage loan. So in the last part of the demo, we can talk about access rights. And as mentioned before by Shraddha, it's very important to protect sensitive information. Not all the member of a fraud analyst team could be has the right to see sensitive information. And we have that the access to information in Linkurious Enterprise is enforced by an embedded access right layer. Basically, with this access right layer, you are able to define a specific right access for every node category and for every edge types. The access right works with the groups. Basically, every users can be assigned to one or multiple groups. And according to this kind of groups, the users will be allowed to perform some actions and to see certain informations. And if this is not enough, by turning on the property key access rights, the right can be defined at the property level. Let's jump again into the demo. So right now I'm a senior analyst, and by expanding Timmy Greenbot, I can see basically all the information. I can see sensitive information such as the phone number or the email address. And moreover, based on the data source schema that has been defined from my bank, I have also some sensitive information inside the person node. So I have the address, I have the annual revenue, I have the profession, and so on. As admin, because I'm also an admin, I can define new groups, and this can be done by going on the admin menu, users and groups. And by clicking on the groups tab, right now I have only one custom groups, that is a senior analyst. But in my company, I also have some junior analysts. Junior analyst is an analyst that is not allowed to see sensitive information. So I need to modelize this group. I can create a new group, and I can give it a name, like in this case will be called junior analyst. Here I can define all the action that this group of users will be allowed to execute in Linkurious Enterprise. So this user can only run queries, can only run custom action, and can process alerts. And if I click next, as you can see here, you can see all the node category and the hash types that are actually in my database. So these users will be only allowed to read all the category except for the email and phone nodes. The same is for the edges. So I can set up the default behavior in read for all the edge types. But once again, I want to remove the hasmail edge and the hasphone edge. So now I'm done. And as you can see, I created a new group. So let's say that I have a new member in my company. I want now to assign this new member to the new group. So what I can do is to switch to the user tab, going on the users, click on edit. And what I can do is to assign him to the junior analyst group. As said before, in my data source schema, I also have some sensitive information modelized inside the person node. And of course, it's something that I need to remove. So I need to prevent the junior analyst users from reading this kind of information. In this case, what I need to do is to turn on the property key access rights. That can be done always in the users and groups page. By clicking here, I can switch on the new feature by confirming I'm now in the property key access right mode. And if I edit again the junior analyst group, and if I go to the access page, access rights page, as you can see now the page is slightly different. And in fact, if I click on the person node, I can see all the property that are contained inside this node. So what I want to do is to remove sensitive information. So what I can do is to remove the access to the address property, to the annual revenue property, and maybe also to the profession property. I can save it. And now I basically create a group that is compliant with the bank company, where the junior analysts are not allowed in any way to see sensitive information. In fact, now if I sign out from my admin account, I can log in as a junior account. And if I search for Timmy Quibot, as you can see, the node is still a suspicious node. This is something that has been modelized before with the pre-template. But if I expand the node, the asphone and the asemail edges and nodes are not available. And if I expand the nodes, the sensitive information has been removed. So this is something that can really help you in keeping the privacy of your customers. So we reached the end of the demo, and now we need to wrap up.
Thank you, Andrea, for presenting. So to briefly summarize and give you some key-aways quickly, Linkurious is an intuitive graph visualization platform which helps you make most of your investment and give you a good ROI. It also helps you to provide seamless and faster insights, which creates value for your analysts and your company. It can streamline your operations as it is easy to incorporate, as you just saw in demo, within your application, within the same ecosystems you're working in. And last but not the least, you can safeguard your data by setting up the correct access rights. So to conclude, Linkurious Enterprise is offering you a very beautiful landscape, which you can explore through eyes to detect threats, to make investigations, etc. That brings me to the end of our presentation. I want to thank you all from the team of Linkurious for your time and attention today. And without further delay, I would hand it over back to Deepak. Thank you.
Thank you so much, Shraddha and Andrea. And now I will request our guest, Nishant Goyal, to please take over. Nishant, over to you.
Thank you so much, Deepak. I must say Shraddha and Andrea has very well articulated the powerful graph intelligence tool. Good morning, good afternoon, and good evening to everyone. I am Nishant and I am part of LTI data engineering team. It's my pleasure to be part of this prestigious webinar where I would be presenting our success story, collaborating with our partners, Linkurious and SoftLink. We all know picture speaks louder than the numbers, and number in discrete way do not make any sense unless they are presented relatively for that purpose. We had the similar requirements of building a platform that can create a visual analytical engine to deal with billions of records. And in this context, 100 million entities and 500 million relationships, which is still growing. As an organization, mostly, we wanted to make sure we do not make the same mistake which a lot of other organizations do, which is failing to articulate the needs from the graph visualization tool. Our focus potentially was to specify our analytical needs and inference we wanted to draw to enable business growth and avoid any suboptimal decisions. We started our journey from the same point. As we do in most of the industry, with a big question, build versus buy. We explored various options in terms of leading graph visualization tools as well as bespoke development alternatives. Some of the consideration we had were user friendliness, how much customization is possible, and time to market. We had written what we desired from this solution, which gives me a flexibility to search as per my requirements, be it be a fuzzy search, be it be a like search, or even property-based search. The questions which were in our mind at that time were, can I expand my view? Can I zoom? Can I modify or select a specific node or group of nodes so that there is a bi-directional communication? I think this is very well covered by our partners when they have demonstrated the same thing, how we can interact with the network over there. I wanted to know how many, how my data behavior is changing over the period of time. Like how many new relationships were added, how many new entities were added over a period of time. So how my graph is expanding or contracting year on year and month on month over the time dimension. So time dimension was another very important feature for us to see how my graph is evolving, how the relationships are evolving, how many new entities or entities were being added over there. So that's another very, very important parameter for our consideration. Definitely another important piece was out of the box support for all the powerful graph algorithms to provide descriptive and prescriptive analysis. Our dear friend Shay will be covering that point in the coming demo, that how we can use that powerful algorithms in this visualization tool. We wanted to convert the knowledge into actions with a seamless integration with other systems. Now, what we are identifying in the graph were patterns. And these patterns help initiating cases, initiating investigations. So that's how we wanted this visualization tool to speak, to talk to other case management tool to initiate cases. Every individual has its own liking and they want to see these visualization tool based on their likings. So personalization was another key aspect. Deepak, it looks like my screen is hanged. I am trying to move to the next slide. So our search ended when we found our partners Linkurious and SoftLink. We have decided to work with them based on their credential for this large and prestigious program. Linkurious is very powerful graph visualization tool. It provides enterprise smart search feature with underlying Elasticsearch empowered solution, which helps us deal with the various option of fuzziness like search in a very, very fast manner, in a sub-second optimal manner. It integrates well with other application using various ways. You call it and it is there. Be it be a REST API, be it be a file-based exchanges, or be it be any other graph formats. It is all available. Everything is inbuilt. You just have to call an API and you are there. What you see is what you feel, showing a story on a visual front with sizes, shapes, colors of node and relationships give the real guided analysis. So we all know that in a visual aspects, we see a lot of nodes, we see a lot of relationships. But for example, I am investigating a case where a particular turnover of an organization is important. I can configure the solution to show that node size based on this input and a combination of others as well. So if an investigation officer is seeing a network graph and a size of a node is expectedly larger than others, then we are on the right track. The investigation officer will be knowing which entities to be dragged further, right? Or investigated further. Various experts in their fields wants to collaborate. When we are doing a collaborative analysis, we invite multiple investigation officers because they are experts in their field, and to reach to a conclusion, which is a kind of a combined analysis, or bringing the data or expertise from the various sources. Another feature which is available out of the box is collaborative analysis. Analyze, save, and share. As simple as that. Once you find a pattern in the case, definitely you want to run that pattern as a alert. So we have already found certain patterns. Now we want to see whether the similar patterns exist in the entire graph, in the entire network. So that is as simple as just click of a button. You provide your pattern to the tool and you are there. The tool will give you the outcomes, the various patterns, various entities and relationship graphs in the moment of time. Then you can very well say whether that pattern, whether that output is something which you want to take it to the next level or you want to reject that pattern. So it's as simple as that. It is UI supported. Everything can be configured by the power users. The next important aspect, and probably most of the question from the data privacy perspective and other laws perspective, is what an investigation officer can see. So here comes the user personas and access control, where an administrative user can control the access right to nth level. What one can see, what property one can see, what entities one can see, what relationship one can see, can all be configured. Now, I really want to steal some thunder from my partners. They have provided us a very solid analysis tool, but it is very important to understand the business domains and the objectives and what you want to achieve from these use cases. Configuring the solution for one-click analysis is what we did for the client. We understood the domain end to end. We understood the user requirements end to end. We understood how important a network can be. What is the analysis which these typical investigation agents or officers wants to achieve. Having a thorough understanding of domain, we have our own experts within LTI, and we have created a guided story for the users. We have created the wireframes. We got the approval from them, and then we have configured the tool, and it has come out wonderfully well. What we achieved was we have created a lot of good use cases, and some of the big bets which we have implemented was creating a high risk network of the related persons. We have identified suspicious purchases and payments, circular transactions, as we have demonstrated earlier. So if, for example, if company A is dealing with company B, and company B in turns is dealing with C, and most of their sales and purchasing is happening within this loop, that is a primary pattern for circular transactions. Then we have identified ownership chains, that a particular account may belongs to a various owners, right? But what is the primary owner for that account or a particular transaction is what we were able to identify clearly from this analysis. Then we have created communities, and I'm sure that Shrey is going to cover that part, but we can create communities within a network, and these community can further be analyzed. So that is why we are helping these investigation officer to zero down to a suboptimal or optimal network, which can be further analyzed, saving a lot of their time. I must tell you, this is a great success story for us as well as for our partners and the customers. So that is how we have done this wonderful implementation, and we got a great support from our partners and the customer. So now I conclude and I hand it over back to Deepak. Thank you, everyone.
Thank you so much, Nishant, for the wonderful talk. And coming from you and LTI, it makes a lot of difference. Thank you so much. So finally, we will have a small demo from my colleague Shrey. Shrey, can you take the control?
Yes, Deepak. Thank you so much. So just taking the control.
Yeah.
Please let me know when you can see my screen.
Yeah. Yes.
So guys, welcome. Today in the short demo, I'll be taking you through the eyes of a data scientist. So the first case that Shraddha was explaining of finding out suspicious patterns and finding out fraud. Well, how would we do that? We saw Andrea flagging certain entities in the nodes as suspicious. But then as an investigating officer, when I'm presented with the data, how do I know which one is suspicious or not? Because I'm just being presented with the data everyone has. So what we do is we define this journey as going from a basic property graph to an actual knowledge graph. And how do we do that? By extracting hidden insights by using algorithm and analyzing the graph structure, the global graph structure through algorithms. So these algorithms include centrality, community detection, and pathfinding. We will come to the algorithms that we have used in this demo as well a little bit later in these slides. So before we do that, let me take you through the schema that we're going to analyze today. We assume that the data has already come in and we've modeled the graph out of it. So now how do we extract things through? So this data is relatively simple. It's for the mobile wallet transactions like PaySim, Google Pay, Paytm and Google Pay, etc. So what we have here is a very simplified schema. there's the client node, which is me, you, anyone else who uses their mobile phones for payments. So the client has a phone number. He has a social security number. In India's case, it would be an Aadhaar number or a PAN number. And he also has an email ID. So these three pink entities are called personally identifiable information. Then the client does transactions with either a bank or a merchant. So, and these relationships are whether it's the first transaction, whether it's the last transaction, etc. So this is okay. We don't have to pay much attention to this. Our entire demo is based on the personally identifiable information of the client, and we'll show you how very intuitively, even without the knowledge of the domain, one can use Linkurious Enterprise along with the graph data science library to really extract and enhance their graph visualizations and graph analytics. So let's come to the algorithms that we'll be using in the demo. But before that, let's check out the recipe. So what we will actually be doing, we'll combine three algorithms: the weakly connected components, the similarity, and the degree centrality. So how will we start? We will first identify all the clients that share their personal information. So these three, each a client that is sharing his phone number, social security, or email with someone else. So generally that's kind of suspicious, right? Because you don't share your Aadhaar card with anybody else. Like nobody has the same Aadhaar number as you have. And if they do, then there's probably some suspicion involved. So on. We'll first identify those clients. Then we will cluster these clients using the weakly connected components algorithm. So this is a clustering algorithm that will create communities of connected nodes. We will then find client nodes that are similar to many others. So in each cluster, which client nodes are similar to each other using node similarity. So this is another algorithm that we do. So once each client has similarity scores with them, then we will use these similarity scores to find the central client or the most influencing client in this cluster by using a degree centrality. The degree centrality is a relatively simple algorithm, and we'll come to all of these in the next slide. So weakly connected components, quickly, it uses a monopartite projection, which is when you project your graph in memory, which is also another brilliant feature of this graph database, where you can take a big graph, you can take a subgraph out of it, project it in memory, utilize all your algorithms on it, and then write the results back into the database. So in this projection, all the nodes will have the same label. So all of them are colored red here as to show us have the same label. And what WCC will do is it will create communities out of A, B, and C, which will be one community. D and E will be one community. F, G, H, I will be another community. Why? Because A, B, and C are connected. D and E are connected. F, G, H, and I are connected. So if there's a connection going from one node to another node, they will be engulfed into one community. That is the weakly connected component. This is used for clustering. Similarity is now used for calculating how two nodes are similar to each other. For example, C and B are some personally identifiable information. A and D are clients. Using node similarity, we will find out that A and D are exactly similar to each other. Why? Because they share the same clients, right? So this takes in a bipartite projection, which is the nodes in the graph projections have two labels, max. So here we have the personal information, which is one label. Then we have the client nodes, which is another label in blue. Next is degree centrality, which is quite commonly used and relatively simple. It's the degree the node has, the count of connections within each node. So this node has 6 connections, right? Incoming connections are 6. So 1, 2, 3, 4, 5, 6. That's why it's labeled 6. So this count will be for degree centrality. So let's quickly have a look at the demo now. Right. So this is the Linkurious dashboard that we've come into. So first, we're going to do this in 4 steps, right? So the first step was create the shared identifiers relationship. So what this will do is it will identify clients that are sharing this personal information with each other. The personal information is in the graph like this. So if I search for any client and then I say expand on social security, okay, and then I check another client and then I expand on social security again. So right now these are not being shared. This is not the same, but if they were the same, then it would create a new relationship between these two clients that yes, they are sharing one personally identifiable information. So let's launch this query. We'll run this query now. So now you can see that these clients are sharing the personally identifiable information. So if I was to figure out which one, so now you can see that the Sydney and Jacob have the same social security number, right? Because this has SSN relationship is the same for these two. So clearly there's something wrong. Okay. The next step now is to create communities of the clients that are sharing this information. So we will go to our next query, which is the WCC algorithm. So you see, this will do 4 steps in one single query, and you can run this by just the touch of a button. So it will create that graph projection that we were talking about, which will take only the client nodes and this shared identifiers relationship that we've just created into memory. Then it will run the clustering algorithm on this projection, write the results back to the database, and show you the fraud rings that come up. Let me just run this. Oops. Oh, sorry. Of course, there are always certain technical difficulties when we go through this. So let me just quickly install the plugins that are needed. Just give me a minute. I apologize for this. Just install and we start with. So as I said before, you need the Graph Data Science Library plugin to run these algorithms. These algorithms are a set of predefined algorithms that are mainly used for the graph. And algorithms such as community detection, centrality, and similarity are already fully optimized to run on the graph. So let us start the database again. And as you can see, it's starting. So with the help of these algorithms, you can really get your hidden insights. Now we've created an entirely new relationship called shared identifiers. Now we will cluster the algorithms once the database has started, which is taking some time. So we'll wait for it to start. Yeah, so it's active. So let me refresh my screen. And yeah. So now we'll run the weakly connected component algorithm. Yeah. So now we've created these clusters out of our fraud ring. So how do we know that each cluster is the same? Well, this client has a property called first party fraud group, which is of 9. So each client in this first party fraud in this cluster has the same first party fraud group. So this is basically your cluster ID. So now we have really clustered each clients according to their relationship of shared identifiers. And it's really visible here in this. You can say this is kind of a fraud ring where the Samuel, Hayden, Abigail are all sharing the same email. They're sharing the same social security with one more person. So this social security is shared between 4 people. So this is clearly there's something wrong here. And clearly there's grounds of suspicion here. However, still based on this information, there could really be a lot of false positives. So we have to get rid of those false positives somehow. So how do we do that? Well, we'll refine our search even further. So now we'll go to the next step is now we'll find the nodes that are similar to all other nodes using similarity algorithm. So what this does is it will create another similarity graph projection that we talked about earlier. It will run and mutate the existing graph projection with a similar to relationship. So each client which is similar to another will have a relationship going between them called similar to. Controller, this one, right? I'll refresh this. So guys, so the similar to relationship now will have the similarity score within them. So client is similar to another client with a certain score, right? And then it will write the results back. So let's now run the similarity algorithm as well. Oops. Yeah. Oh, okay. And, yeah. Let me just run this similarity again. Right. And now we will run. Okay, so the similarity algorithm has ran. And now after the similarity algorithm is run, we will create the degree centrality algorithm. So this degree centrality algorithm, it runs on the same similarity graph projection. It writes the results back into the database, and then it will create the labels having fraudsters more than a certain centrality score. So this score will be more than a certain threshold. So we've already created the similar two relationships. Now we will create the similarity graph projection as well. So let's write the results of the degree centrality algorithm back into the graph. So the threshold, we can define it dynamically as a parameter here. So we define it as 0.8, which is basically the 80th percentile. Yes. So now our degree centrality algorithm has also run, right? So each client has now been identified as a client and a first party fraudster. So it took. So now let's go back and let's see the fraudsters that we've now identified using the degree centrality. Yeah. Okay. So now we've identified all the clients that could be fraudster. Could you see my screen? I felt my screen was paused for a minute. Okay. So we've identified all the fraudsters now. And now when I run this query, which is really nothing more than just a simple query, which is just showing me this first party fraudster. So what we've done is we've scored the degree centrality score, and from that we've created a new label for where each client can be a client or a first party fraudster, where he's been sharing his information, he's been attempting, he's similar to other clients. So you can see a lot of synthetic clients will come into these. So let's run this query now. So all you can see is that this client is a client and a first party fraudster. So now what I can do now is, if I want to flag these clients as a first party fraudster. Okay, there's something wrong. Let me just quickly refresh. Yes, okay. So let's run the query again. Yeah. So now, if I want to flag my first party fraudsters, what I can do is just change this color to red, right? So all these clients now that were previously just clients are now also first party fraudsters. So I've just limited this visualization to 25. Of course, there are more. And now if I expand along my, say, social security, you will see that all of them have some suspicious way. So all of them are sharing their social security number. And they're all also part of the same first party fraud group. So they're all part of the same structure. They have about a 2.3 first party fraud score, which is really high, considering the maximum score that it's just 3. And now I can also say apply some filtering here and say that my first party fraud score should be no less than, should be more than 2.5. So show me all these group nodes that I have more than a score of 2.5. So now I have my most suspicious node ready for me. And now this database is ready to be transferred to the case officer or the investigating officer, saying, these are the guys you should investigate, and you can now go and investigate a little bit further. So thank you for your time, and over to you, Deepa.
Thank you, Sunny, for the great demonstration. Guys, I think we have run out of time. So we have recorded all your questions, and individually we'll be answering each one of them. Someone from the SoftLink team would be getting in touch with you to answer these questions and your queries. And apart from that, we have recorded this webinar, and I'll be sharing the link with all of you who participated. So guys, thank you so much, and thanks to Andrea, Shraddha, Nishant, and Shrey for the great session.
Thank you so much, everyone.
Thank you so much, guys, for your time.
Everyone.
Thank you, everyone, for joining in.
Thank you, everybody.
Thank you, and
Deepak.
bye-bye.
Thank you, everyone, for joining.
Thank you. Bye.